Let's start this question. It's my first video I made today. So minimum operation to make all array elements equal. So you will give an array nouns. You can go through this question, and then you just need to care about this one: increase or decrease an element of array by one. And you can see here the answer is the minimum number of operation to make all elements of the non-array equal to the query. So now you can see here query had two elements. You can see each element is target. So now each element in the non-array should be equal to one. So now you have two choice, right? You can increase each element or decrease. Everything depending on the target. So now you can go through this explanation. Now, this question is a little bit hard to explain, but I will try my best to solving this question. Now you can see is our output is input queries. Now this question you can use the binary search under prefix sum. Why we need to in the prefix sum, I will tell you later. So in this question, before you start the because we are I using the binary, right? So I'm not sure, do you know, before using the binary we make sure we need to sort it in the array in ascending order or descending order. It doesn't matter, so we need to sort it. So you have to remember this rule. And then I didn't create the binary search function. I just directly use the binary function. It's the built-in function. You can use it. Now this function accepts two parameters. The first one is an array, and this array should be sorted. And then second one you can understand is target. And then finally then we find out the target is present in the array or not. If yes, then we return the index. Otherwise, return. I will show here. Now we have this array. You can see this array is already sorted, right? Now we have like 3. Now we know 3 is present in the array, right? Now here we return the 1 as the output. Okay, very simple, right? Now, for example, if we have -2 as target, what is the output? So now, because we know the -2 is not present in the array, right? So here we need to check this one. -2 is smaller than the first value. So now we return -1 as output. You just remember this one. If the target is smaller than the first value, so just return -1. Or we passing 10 as target. What is the output? So now output you should be following this way. So we know the size of the array is 4, right? 4 plus 1 and minus this sum of value. So we will get -5. So -5 as output. So you should remember, this one depending on the length of the array. If the length is array 6, okay, just 6 plus 1 and just return -7. So you just remember how to use this array binary search function. You just remember this one. Now when we figure out this one, after that we need to create a prefix array. So now I'm not sure, do you know how to do the prefix? Hopefully you know that. Now because here we know the original array have 4 elements, right? So now here we have 5 elements in the prefix array. Now in the first one we need to fill 0, and then here's 1, and then we point to here 3. 3 need to add to the previous down 1. 1 plus 3 is 4. Now 4 plus 6 is 10, right? 10 plus 8 is 18. Okay. So why we need to do here? So actually, I didn't mention why we need to the binary search tree, right? So now the question already say we had two operation, increasing and decreasing. So 1 second. Okay. Okay, here. So we know, for example, we use the phi as target. So we know phi is greater than this portion, right? Because one, because you can see here one need to increase 4 times, and then one will become 5, right? Now here 3 need to increase, need to perform two operation, and then make the 3 equal to 5. And now here 6, right? 6 greater than 5, so here need to decreasing by 1, and here is decreasing by 3. And now we add this all the sum of this value, we will get 6, 7, 10. You can see here 10. So we need to make 10 operation on this target. So you can see it's two portion, right? It's this subarray, elements in this subarray, you can understand is left portion. So we will divide this array into two portion. This one is left portion. Element in the left portion should be less than the target. So you can see 1 less than 5, 3 also less than 5, right? So we say, okay, this one is portion, a left portion, this one is right portion. You can see each element in the right portion greater than the 5, right? So here, right portion we do one thing. We need to increase. Oh, sorry, we need to do the decreasing operation. And left portion we need to do increasing operation, right? So now maybe here you can know here's 7, right? It's 5, right? So for example, if we have one more target, it's 7. So now we know we have two portion. The first portion should be the 3 elements in the left portion, and the A in the right portion. So right is very simple, right? So now, so why we do the prefix sum? So now, because we don't need to go through this array again and again. So now, for example, so we have left portion. You can see it's left portion, right? The 3 elements in the left portion, we mean we need to do maybe 1 second. Down unit 7. Let me unit 5. 5 as target. Now 5 as target. So now we need 2 elements in the left portion, need 2 elements in the right portion, right? So now can we do this way? 5 times to 10 minus 4. Oh, sorry, it's not times to 10, it's times to 2, right? Because here only 2 elements. Left portion only 2 elements. And minus 4. Why here's 4? Because we sum up these 2 elements, we got 4. So now 10 minus 4, what we get? We get a 6. So which means we need to make 6 operation on this left portion. Now here, now you remember we need to make 6 portion, perform 6 operation, right? Now here we can understand 6 plus 8 is 14, right? 14 minus 10, 2 times to 5. Because we know each element in right portion should greater than 5, right? So now we need to 14 minus 10, so 4. So now we need to perform 4 operation on this right portion. So now we add this 6 plus 4, we got a 10. You can see here, right? We got the answer. So that's why here I use the binary search. Binary search can quickly find out the prefix sum, right? For example, so okay, for example, now let me remove this one. So we know is right, is left portion, this one is right portion, right? So now, so we know here is index 2, right? So we index mapping to here, so it's 4. We know 1 plus 3, we got the 4, right? So it's same thing, right? We do the time, or in the 2 time to find, we got the 10. 10 minus this prefix sound, because we know here is in a left portion, so minus 4, so we got the 6, right? So now, how to get the right portion? We know here we use this one last prefix sound 18 minus here, because we need to get this portion, right? So we need only 18 minus 14. We will get this 6 plus 8. We got 14, right? So it's really easy to get a left portion, the sum of left portion, and the sum of right portion, right? So you can see here one more example, maybe can make it easy understand. You can see here when the target is 5, so we know we have this portion. Oh, sorry, let me use the color. We have the left portion just only 2 elements, right portion also 2 elements. But if we have target is 7, so now you can see here, there should be 3 elements in the left portion, and just only 1 element in the right portion. So for example, we have 2 elements in the queries, right? So each time we have 3 elements, which means we need to go through this array 3 times. If we have 1,000 elements in the query, which means we need to go through this array 1,000 times, because we need to find the left portion, because different number have a different number of elements in the left portion, and a different number of elements in the right portion, right? So here we need to, if we have 1,000, we need to go through this original array 1,000 times, right? It's not efficient, so we need to reduce the time capacity, right? So that's why here we use the prefix array, because we don't need to go through 1,000 times. We just directly get an index, and then when we get an index, we just pass in the array and the target, and we will get an index, right? We will index. Now we quickly know where is the left portion and what is the what sound is the right portion, right? So we know here get this one. So we know here is the sum of left portion, and then this one which is to 18 minus here, and then we will get the sum of right portion. So that's very simple, right? Now here, I just told you why here I use the prefix array. So they just help us to reduce the time capacity. And then, 1 second, let me remove this one. So now here I will show you the formula. So now let me type it. So we have the left portion. You can understand this way. Now we can use the middle index. So we will get an index when we pass in the non-array and the target. So let me remove this one. Time to target, right? Maybe here I use the 5. So here need to return time to find time. And then we need to prefix in the middle. So we will get the sum of left portion. And then right portion we can prefix here's a minus prefix veto, right? And now also q time to a minus middle index. So now we will get a sum of right portion. So hopefully you can understand. Maybe I didn't do well. My explanation is not very well. So, but I still hopefully you can understand. If you could understand, just let me know. Yeah, I will use. Maybe I will record one more time. Now let's code it up. Now because this one is the return type, right? We need to create this one. Now finally we need to return res. And just I mentioned, let me get the length. And then we need to sort it, right? After sort it, we need to create a prefix equal to +1. Now here we need to go through this array. The prefix sum plus the period noun, this number actually is current number, current value. Now it's -1. Now after finish this one, now we need to call. We need to go through this query array. Now we need I equal to this query, or we don't need to use the we can make simple. We can queue queries. Now we need to middle index, right? So we need to call the array dot banner search. It's built-in method you can directly use. Now we need to pass the array. The array is nouns, and we need to pass the target. Now in middle index less than 0. So I already told you, right? It's possible it's not present in the array. So it's not present in the array. You need to know what is the output. So here middle index equal to minus middle index +1. Now here we need to do the left. So just use the formula I already told you here, right? To use the two formula, and then finally we just sum out left portion, right portion, and then you will get how many operations you make in this target. Now time to run q minus previous middle index, right? So it should be middle index. It's wrong, right? Just prefix n minus prefix middle index and minus wrong. Here you see the return type is wrong, so you can see the constraint is really big, right? Is each number maybe is 10 to power 9. It's very big. You need to take care of this one. Otherwise, it's easy to get the time limit. Now, q a minus middle index. Now, finally, we need to add left plus right. Let's see. Okay, pass on the test case. Okay, you can see. Let me run it again. Sometimes it's 63. Sometimes It could be better. Oh no. We can submit it again. Oh, okay, still here. But you can try one more time. Before I got here is 93. So the time complexity is because I saw it right. The time complexity is b of n log n. The space complexity is also it's not n log n. The space complexity is b of n because I used the prefix, right? Prefix array. Now, thank you for watching this video. The logic a little bit hard to explain, so not sure you understand or not, but still thank you watching.